Okay, fearless factoring, FACT. Okay, spelled that right. Or crisscross method. We'll do two examples. The first one is a simpler one, similar to what we've done before. So in this method, we're still looking. What we're going to do is we're going to list the factors of the first term and the third term here. Okay. Now, depending how large these numbers are, this can be cumbersome. But in this case, pretty nice. My first one is a prime number, right? So I have 3 and 1. And what I'm going to do is, because this is x squared, I'm actually going to apply an x to each of these, okay? This, including the variable, will come in really handy for when we get a question like this that has multiple variables in it, okay? While we don't normally have to do it if it's set up as like a quadratic relationship, this one, which isn't quite quadratic, it has extra variables. Using this, including the variables, will help with that. And then we list our factors of 8, which are 1, 8, and 2, and 4. Awesome. We're going to almost build little columns around them because they have to work in their pairs, okay? And then we're looking for numbers that when multiplied together, so you get your products here, their sum is equal to whatever our middle term was, which in this case was 14x. We're going to keep the x, okay? That way we don't have to make any changes with the variables. So when we do some testing here, I'm just going to go straight across. 3x, we'll do this in red. 3x times 1 gives me 3x. And 1x times 8 gives me 8x. I add those together, 8x and 3x, that's actually 11x. So that doesn't work out. Let's take those away. Okay, now I've gone straight across. I'm also going to go diagonally. And the reason I'm doing this is so that I'm systematic and I can eliminate one of the options this way. So 3x times 8 gives me 24x. And 1x times 1 gives me 1x. And again, the sum of those two, I should have put a plus sign here. I'm going to have to get rid of that. Does not equal 14. So we're going to take those away also. And get the sum here. The reason I did it that way is so we've gone straight across and diagonally. This is definitely not a column, okay? Which is great. If this can be factored, then we actually know these are the numbers. We just need to know what order they're in. I like to go straight across the test first. 3x times 2 gives me 6x. 1x times 4 gives me 4x. That's actually 10. So we're hoping that it's diagonal here. 1x times 2 is 2x, and 3x times 4 is 12x. Hey, that worked out. Good. So we've got our columns, and the diagonals are really important. You might say, we already knew which ones, but what becomes the important part is we now jump right to the very end. We jump to our factored form. The first column, which is our 3x and our 1x, will be the first terms in each of the brackets. So I have a 3x and I have a 1x. You don't technically need the 1, you can just write x. Then this second column here will be the second terms, but the question is which bracket do they go into? So if we decided that 3x was times 4, they have to be in opposite brackets, okay? So since 3x is in this bracket, the positive 4 has to go in the other one. And since the 1x was times 2, they have to go in opposite brackets. So the 1x is here, the positive 2 must go there. This is it. This is our final answer. We can use FOIL to go back through and check it out, but that's it. We've jumped right to the end of the factored form. So using that algorithm, let's take a look at a question that has a little more to it. 15. Well, 15 has a lot more factors. We can do 1 and 15, and again, I'm going to take that x because it's squared, and I'm going to split it amongst the 2. 2 doesn't go in, but 3 does. 3x and 5x. So right off the bat, we have 2 columns for our first term. And then, well, luckily, our third term here, so we've dealt with the first term. Third term is just going to be 2y and 1y. There's no other way. Okay, so not so bad. Our numbers are going to be added together, whatever they are, to our middle term, which is negative 7xy. Now, you may look at this and go, actually, I had a negative 2, so I have to apply it here. We don't actually know which one we're going to apply to, whether it's going to be the 2 or the 1. So we leave it off, and then we test with it after. So let's try this crisscross method again. We'll start with the first column. We'll do 1 times 2 and 15 times y. That's going to give us 2xy and 15xy. Now, if I'm going to test, because there's subtraction here, I'm going to test both adding and subtracting to see if I get it. No matter how I split that, I either get 17 or 13. That doesn't work out. Oops, am I losing it? There we go. Those don't work. And if we go diagonally, we get 1xy and we get 30xy Again, add or subtract, doesn't pan out. So what we've just done is systematically eliminated the first column. That's done. Do the same thing here. We'll go straight across. We get 6xy and 5xy. Add and subtract does not work. Looks like it's always the last one we try here. 3 and 1. So we got 5x times 2y gives me 10xy. And then 3x times 1y, that should be a y, gives me 3xy. If I add them, it doesn't work. But if I subtract, so in other words, one of these must be negative. Do I need the 3 to be negative or the 10 to be negative to get to -7? That's what I have to figure out. The 10 has to be the negative, which means, well, what do we multiply to get the 10? We multiply by that 2, so that 2 has to be the negative. That's how we figure out where to apply that negative piece, okay? That's the only tricky part when we have a negative. Now that we've done that, we jump right to the end. Again, we have 2 brackets. We know this is our first column, so 3x, 5x, and then just make sure they're in opposites. 5x is times -2y, so they have to go in opposites, so this becomes a -2y. And the 3x and the 1, this becomes a positive 1y or y. And that's it. We have factored again. Really in a tight little space too, because considering some of our other factoring methods, we have to do a lot more there. So that's it. We've done the crisscross method for 2 different ones.